The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to section 9.2. Rational expressions, or excuse me, rational exponents. And we have the following idea. If you have, let's say, the nth root of x, and we wanted to write that radical in exponential notation, that would become x to the 1 over n. So the index becomes the denominator of a rational or fraction exponent. So for instance, the cube root of 8 would be 8 to the 1/3 power. Well, what about the cube root of 2 squared? That would be 2 to the 2/3 power. So the exponent inside gets to go on top, and the index goes on the bottom. So we now have a fraction exponent with a power and a root. All right, now, all the rules that apply to exponents also apply to radicals, also apply to exponents that are rational or fractions. We've looked at positive and negative and zero exponents. Now we're going to be looking at fractions as exponents as well. Let's say we've got 125 to the 1/3 power. That is the same thing as the cube root of 125. But how could I put that into my calculator and come up with the answer, which would be 5 in both cases? Well, I'm going to put in 125, then I'm going to use the little caret key, which is over on the left column. Looks like this. Then I've got to put parentheses 1 divided by 3 close parentheses. And when I do that, 125 raised to the 1 divided by 3 power, I get 5. I have to be careful though. If I write it like this, I won't get the correct answer because the calculator reads that as 125 to the 1 power divided by 3. Okay, which will not give you the correct answer. Let's see, 125 divided by 3 is like 41.6 repeating. Anyway, you want to put a grouping symbol around the exponent so the calculator knows that all of the 1/3 is the exponent, not just the 1. Okay, what about this? 81 to the 1/4 power. So that's like the 4th root of 81, which is 3. How about negative 1,000 to the 1/3 power? Well, let's see, that would be negative 10, because negative 10 cubed is negative 1,000, and the 1/3 power is the same as the cube root. So again, the denominator of the exponent is the index of its radical equivalent. All right, now, this says, simplify each expression, assume that the variables can be any real number, and use absolute value symbols when necessary. Okay. So we've got 4x squared to the 1/2 power. We have a product raised to a power. So we're going to attach the outside power to each factor inside. So we get 4 to the 1/2 power times x squared to the 1/2 power. 4 to the 1/2 power, that's like the square root of 4, which is 2. A power raised to a power, you multiply the exponents. 2 times 1/2 is 2 over 2, which is 1. X to the 1 power is just x. Now, Do I need absolute value bars here? Let's see. Well, I'm taking a square root, an even root, so I have to make sure that my answer isn't negative, and it could be under its current conditions, so I need that. Okay. What if I had this situation? 4x to the 4th power all to the 1/2 power. That would be 4 to the 1/2 power x to the 4th to the 1/2 power, which is 2x squared, because a power raised to a power, you multiply the exponents. 4 times 1/2 is 2. X squared isn't going to be negative, so I don't need absolute value bars there. What about this situation? X cubed to the 1/3 power. A power raised to a power, you multiply the exponents. So this is x to the 3/3 or x to the 1 or just x. I don't need absolute value bars here though, because even though x could be negative, that's not a problem because we're taking an odd root. Okay, cube root, odd root. All right. Let's see, what about this situation? Negative 16 q to the 4th power, all raised to the 1/2 power. So again, I've got a product raised to a power. So I'll attach the outside exponent to each factor inside. Well, we're taking the square root of negative 16. We can't do that, so that's not real. This part would give us q squared, but since part of it's not real, the whole thing doesn't work. All right. What about this situation? Let's see, we've got 243 x to the 10th all to the 1/5 power. So that becomes 243 to the 1/5 power times x to the 10th to the 1/5 power. Well, let's see. What goes into 243? Looks like 3 does. I'm gonna put that into my calculator. 243 raised to the 1 divided by 5 power. I'm getting 3. So this is 3x to the 10/5 or x squared. Okay. I can't really do this part on my calculator, but I can put that into my calculator using the caret key in parentheses around the 1/5. Okay, let's see. Now, what about this? 27 to the 2/3 power. If we're taking a power and a root, if both the power and the root give you a real result, you can do them in either order. So in other words, I could take this and do the power first, make it 27 squared, and then take the cube root. Or I could do 27, take the cube root, and then square it. Well, the top one, I can't do 27 squared in my head, but let's see what it is. 27 squared is 729. And then I'm going to raise it to the 3rd, or the 1/3 power. 1 divided by 3, and I get 9. The bottom one, well, the cube root of 27 is 3, and 3 squared is 9. So I get the same result, but in this case, the bottom one I could do without my calculator. When both of them are real, you can do either one first, and it tends to be easier to do the root first. You're taking something, making it smaller, and then raising it to a power, as opposed to taking something and making it huge and then trying to tear it down. Anyway, okay, let's see here. It says simplify each expression. All variables represent positive real numbers. So here we don't have to worry about absolute values. We have 27 a cubed b cubed all to the 2/3 power. So again, I have a product raised to a power. So I'm going to attach that outside power to each factor inside. Going across, let's see here. Oh, 27 to the 2/3 power. So I'm going to take the root and then the power, which would be 3 squared, which is 9. Okay, so this is 9. Power raised to a power, you multiply the exponents. 3 times 2/3 would be 2. So this is going to be a squared. Again, multiplying the exponents, 3 times 2/3 is going to be 2. So this is going to be b squared. So we're going to get 9a squared b squared as our final answer. And let's see here. We have negative 32, x to the 10th, y to the 5th, all to the 4/5 power. So I'm going to get negative 32, the quantity raised to the 4/5 power, x to the 10th raised to the 4/5 power, y to the 5th raised to the 4/5 power. Negative 32, I'm going to take the 1/5 power or the 5th root and then raise it to the 4th power. Let's see. Negative 32. So I'm going to go parentheses, negative 32, close that up, x, or raise it to the power, 1 divided by 5, and I get negative 2. Then I'm going to raise that to the 4th power, which is going to give me 16. Be careful, because if you put this into your calculator, you're going to get negative 16. The calculator is going to take 2 to the 4th power and then apply a negative sign. You need to group that negative as part of the negative 2 base, okay? So this is going to be what? 16. This is going to be x to the 10 times 4/5 would be what? 8. And 5 times 4/5 would be 4. So I get 16 x to the 8th, y to the 4th power as my final answer. All right, let's look at another one here. We've got parentheses 1/16 x to the 8th, y to the 4th, all to the 3/4 power. So that becomes 1 to the 3/4 over 16 to the 3/4, and then x to the 8th to the 3/4, y to the 4th to the 3/4 power. So let's deal with each one of those individually. 1 to the 3/4 power, we can do this in either order. 1 cubed is 1, and the 4th root of 1 is 1. So this just becomes 1. Okay. 1. Let's go here next. The power raised to a power, we multiply the exponents. 8 times 3/4 would be 24/4 or 6. So x to the 6th. Y to the 4th to the 3/4. 4 times 3/4 is 3. So we get y cubed. And then in the denominator, let's see, 16 to the 3/4 power. Let's do the root and then the power. The 4th root of 16 is 2. 2 cubed is 8. So we get that answer. And we could write it like this or like this. Make sure these don't get sucked down underneath as a denominator. Okay, but either way, so you don't want it to be down too low. All righty, let's see here. Now we're going to change a radical expression into an exponential expression. We're not going to simplify it. We're just going to convert it to the other form. The 7th root of 7p squared q would be the quantity 7p squared q, all to the 1/7 power. The square root of x squared plus y squared would be the quantity x squared plus y squared, whoops, to the 1/2 power. let's go the other direction. Let's change some exponential expressions into radicals. 6x cubed y to the 1/4 power becomes the 4th root of 6x cubed y. Let's see here. X cubed plus y cubed to the 1/3 power becomes the cube root of the quantity x cubed plus y cubed. Okay. It says simplify each expression. All variables represent positive real numbers, so we don't have to worry about absolute value bars. And here we're going to be working with negative exponents. So 49 to the negative 1/2 power becomes 1/49 to the positive 1/2 power. Recall that if you have a base raised to a negative exponent, you can rewrite that as 1 over the base and then to a positive exponent. 49 to the 1/2 power, it was like the square root of 49 is 7. 8 to the negative 1/3 power would be 1 over 8 to the positive 3rd power, which would be 1 over the cube root of 8, which is 2. How about this? 25/49 to the negative 3/2 power. We can take the reciprocal of the base, and that changes the sign of the exponent. Now we can apply the outside exponent to both the numerator and the denominator of the quotient. And then let's take the root and then the power. Let's see, 7 cubed. 7 cubed is 343. And here 25 will take the root and then the power, which is 125. Okay, so again, we can do the reciprocal of the base, changes the sign of the exponent. When we have a fraction raised to a power, we attach the power to both the numerator and denominator of the fraction. A power raised to a power, you multiply the exponents together. All these rules are back in section 5.2. So if you get stuck on something and you want to kind of go back to the basics, section 5.2 of this textbook has all of these properties of exponents. Let's see here. Here I have a situation where the base is negative in the denominator. So if I move it to the numerator, it changes the sign of the exponent. I wrote it over 1. I don't really need to worry about the over 1 part of it. I'm going to do the square root first, which would be 4, and then raise that to the 5th power. Let's see, what is 4 to the 5th power? That's 1024. That's supposed to be a 1. Lovely looking 1. All right. Recall that when you multiply 2 powers with the same base, x cubed times x to the 7th power, you add the exponents. So let's say I have this situation, 9 to the 3/7 power times 9 to the 2/7 power. That would be 9 to the 5/7 power. Multiplying 2 powers with the same base, we add the exponents. How about this one? Let's see, 5 to the 1/3 power times 5 to the negative 5/3 power. Well, that would be 5 to the 1/3 plus negative 5/3, which would be 5 to the negative 4/3, which would be 1 over 5 to the 4/3 power. So unless it tells us otherwise in the directions, we want our final answer to have just positive exponents. About the only time you leave it with negative exponents is if you're dealing with scientific notation, and we're not dealing with that today. Okay, let's say we've got b to the 5/3 times b to the, excuse me, b to the 3/5 times b to the 2/5, all raised to the 8th power. Well, I can simplify inside the grouping symbol first. B to the 3/5 times b to the 2/5 is b to the 5/5, which is b to the 1, which is b. So I end up with b on the inside to the 8th power, which is just b to the 8th power. Let's see here. M n to the negative 2/3 power, all raised to the negative 3/5 power. All right, so I've got m to the negative 3/5 power, n to the negative 2/3, all to the negative 3/5. So this first expression would become 1 over m to the 3/5. The second expression, multiplying when you have a power raised to a power, negative 2/3 times negative 3/5 would be positive, what, 2/5? So this is going to be n to the 2/5 power. So I'm going to end up with n to the 2/5 divided by m to the 3/5. So be careful with all those signs. Now let's see here. 2 to the 5/6 power times 2 to the 1/3 power divided by 2 to the 1/2 power. So we're multiplying and dividing with the same base. Multiplying two powers with the same base, we add the exponents. So in the numerator, we get 2 raised to the 5/6 plus 1/3 power over 2 to the 1/2 power. But if we take the exponent, 5/6 plus 1/3, the common denominator would be 6. So 5/6 stays as 5/6. 1/3 we'd multiply by 2 over 2 to get 2/6. 5/6 plus 2/6 is 7/6. That's kind of hard to say. So now I've got 2 to the 7/6 power over 2 to the 1/2 power. Where multiplying two powers with the same base, you add the exponents. Dividing two powers with the same base, you subtract the bottom exponent from the top exponent. So for instance, let's say I've got x to the 5th over x squared. That becomes x to the 5 minus 2 power, or x cubed. So now this is going to be 2 to the 7/6 minus a half power. Well, 7/6 minus a half, the common denominator is still a 6. 7/6 stays 7/6. I multiply the 1/2 by 3 over 3. 7/6 minus 3/6 is 4/6, which reduces down to 2/3. So I end up with 2 to the 2/3 power. That's my final answer after all of that. Okay, let's see here. B to the 4/5 power times b to the 4/5 power over b to the 3/5 power. Multiplying two powers with the same base, you add the exponents, so I get b to the 8/5. Dividing two powers with the same base, you subtract the exponents. 8/5 minus 3/5 is 5/5, so it's b to the 1 power, or just plain old b. So the whole thing simplifies down to just plain old b. Now let's look at some multiplication where we're going to distribute. Again, all variables represent positive real numbers. Y to the 2/5 power multiplied by the quantity y to the negative 2/5 plus y to the 3/5 power. So distributing, we're going to get this, which is y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. Multiplying two powers with the same base, we add the exponents. So this would be y to the 2/5 plus negative 2/5, which would be y to the 0 power. Recall that a base, any base other than 0, raised to the 0 power is 1. And then here, let's see here, y to the 2/5 times y to the 3/5 would be y to the 5/5 or y to the 1 or just y. So our final answer is 1 plus y. And one more of those. We've got x to the 4/3 multiplied by x to the 2/3 plus 3x to the 5/3 minus 4. So distributing, I get x to the 4/3 times x to the 2/3 plus x to the 4/3 times 3x to the 5/3 minus 4 times x to the 4/3. This becomes x to the 6/3, which is x squared. This becomes x to the 9/3, which is x cubed. And this becomes just 4x to the 4/3. And let's move that subtraction sign down. There. Oh, I messed up. I forgot this 3. My bad. Okay, so those of you that were watching probably caught that. Let's see here. Now we're going to do something that again may seem strange. Maybe it all seems strange. We're going to take a radical expression, the 6th root of 7 cubed. We're going to convert it into an exponential expression, 7 to the 3/6 power. We're going to simplify it. 3/6 reduces to 1/2, so 7 to the 1/2 power. And then we're going to change it back to radical form. Okay, so we're going to change it from radical to exponential, simplify, and then back to radical form. And let's see here. The 12th root of 13 to the 4th power becomes 13 to the 4/12 power, which is 13 to the 1/3 power, which is the cube root of 13. Okay. And let's see here. How about this one? The 6th root of x squared y squared becomes x squared y squared to the 1/6 power, which is x squared to the 1/6 power, y squared to the 1/6 power, which is x to the 1/3, y to the 1/3, or xy to the 1/3, or the cube root of xy. And how about this one? The 4th root of the square root of x. That would be the same thing as the square root of x to the 1/4 power, which would be x to the 1/2 power to the 1/4. Oops, slow down. X to the 1/2 to the 1/4 power, which would be x to the 1/8 power, which would be the 8th root of x. Now, some of you are probably noticing some things where we could shortcut all of this and just take what? The 4 times the 2, and back here we could reduce 2/6 to 1/3 and 2/6 to 1/3. There's some shortcuts there that we'll be talking about later, but if you're noticing those, good for you. All right. We're going to go and use the calculator. We're going to take 15 to the 1/3 power. So on my calculator, 15, the little caret, parentheses, 1 divided by 3, close it up, equals. and 15 raised to the parentheses 1 divided by 3 power. I'm getting 2.466212074. It says round to the nearest hundredth. So that would be, let's see here, this is the 10th hundredth. So we're going to round at the hundredth spot. We go one place to the right, 5 and above rounds up, 4 and below rounds down. So we're going to get what, 2.47. Some of you may have a calculator that doesn't have this little caret key. You might have like a little y to the x button, in which case you push that button instead of that. So you'd go 15 and then y to the x and then parentheses 1 divided by 3, close it up. That should give you the same results if I'm remembering that correctly. Okay. One more here. What about this? Negative x to the 4th to the 1/4 power. What's the base here? The base for the 4 inside is just the x. But the base for the 1/4 outside is negative x to the 4th. So negative x to the 4th is going to be a negative number because x to the 4th would be 0 or positive, and then if you got a negative, so taking the 4th root of that, it's going to be not real. Okay. Oh, it says all variables represent positive real numbers. So we know that x isn't 0. So positive to the 4th power is positive. Negative in front of that makes it negative. We're trying to take an even root of a negative number. Not real. Okay. 3 things I want to remind you of. You can't take an even root of a negative number and get a real answer. When you take an even root of a number that's positive or 0, you can't get a negative answer. And the nth root of a to the n equals a when a is greater than or equal to 0. And you know what? I just remembered that last rule. I gave that to my other class this morning. That's going to come out tomorrow. So scratch that last rule. We'll talk about it tomorrow. Sorry about that. All right, that's all I have for today. So I'm going to stop the recording.